could I then invite our last pitching company, which is Myrspoven, presented by Mr. Anders Kallebo, who is the CEO. Please be welcome.
Thank you very much. Can you hear me and see me?
Yes.
To begin with, good, and also the presentation. Then I hope. Thank you very much for allowing me to come here. It's a big honor. And as you said, my name is Anders, and I'm the founder and also the CEO of Myrspoven AB. We're a Swedish startup that's focusing in autonomous building optimization. I'm first going to, sorry about that. First, going to just mention some short words about our vision. We have what we call a 1% vision. That means that we want to directly contribute to help the global real estate business to reduce its carbon footprint with 1%. And this is a very true vision for us. And for every big decision we take, we sort of try to benchmark it towards how will this affect us on our way here. So we have tried to focus to build not only a scalable technical solution, but also focus on the business model and how we can work with partners, etc., to sort of get our solution out there. So that's very important for us. Now I'm going to mention some few words about what we're actually doing and how it works. Our solution connects to what we call complex buildings. Basically, our sweet spot is commercial buildings, offices, shopping malls, hospitals, etc. Those type of buildings that use a lot of different types of HVAC systems, heating, cooling, variable flows, etc. We connect to the existing building automation system or BMS system. This integration has 4 different purposes. First one is to read the data. The other one is to be able to write data into the system. It includes a fallback system that if we lose connection to the cloud, the system fallbacks to the default set points that was before we started the optimization. And the fourth one is our user face is sent into the existing user interface, which we believe is very important to sort of make life easy for the technicians working on site. So there's not a separate system. We want our system to harmonize very well with the existing system. So through this integration, we get the HVAC data, which is one very important data stream. The second very important data stream is the indoor climate, and that we solve by installing sensors through a third-party supplier if the client doesn't already have enough sensors. But we need to make data out of the indoor climate. Normally, for a normal building like an office, that is temperature and CO2 and humidity. However, we could also work with other types of data streams, such as radon, this radioactive gas, or other types of as long as we can measure it and we have things that actually control it, it could be a potential data stream for us. The third data stream is the energy data. The fourth is weather data, and the fifth is what we call social data, which is social data, basically user behavior. Everything ends up in a database, and then the AI parts come in, where we're using the AI to understand the relationship between how does the indoor climate gets affected by the HVAC system and the user behavior, weather, etc., all the external parameters. The other side of the equation is how does the system, how does the meters get affected of the HVAC system? And when we have that, we can start the optimization, which basically works from a very simple algorithm. How should we operate the building to get the correct indoor climate at the lowest possible cost? And for us, it's very important to work with cost and not only energy efficiency, because nowadays in the new energy system, it has a lot to do with energy tariffs, not only on how much energy you use, but also how and when you use it. So that's very important for us. The key takeaways here is that as we see it, we have a very easy integration, and we believe that's very important for the scalability for the clients. They have a white collar organization that have a lot of things on their table. We try to make life very easy for them. It's self-learning, so it adapts to how the building, the usage of the building is changing. and we have a proven record of having cost savings about 10 to 25%. And the last thing is the business model that I will go into a little bit later. I was specially asked to mention something about that. But just a quick example on basically the effect of putting this technology inside a building. Here we have a normal school, and this is Sweden and the cold period, the winter period. So here it's all about heating. The client had an ambition to have 21 degrees in the building, but as you can see here earlier, the climate was colder, but also it varied a lot during the day. When we started our system, the climate becomes much more stable, and this also allows us for providing the client with even more data on how they should do to optimize the building even more. But the first thing is to get a stable and nice indoor climate. So I just want to bring this very true example on what this technology can do in a building. Now I'm going to mention something short about the business model, and this is very important for us to have a simple business model, not only for the client but also for potential partners. So for us, everything is based on square meter. Either the client can pay a one-time cost per square meter plus a monthly running cost, which is lower, or we can have a pure subscription cost. And we always have a 2-month notice. So we never tie clients to us, so they can freely sell the buildings, or if the cooperation doesn't work for some reason, they can kick us out. And this allows us or our partners or the client to very easy know what this project will cost. So just with public data on the number of square meters and the number of the energy usage is very often a public data for, at least in Sweden, through the environmental reports, etc., at least for public companies. We can say that this portfolio consisting of 1.3 million square meters would cost 4 million euro to implement in a fixed fee. Then you have an annual cost of 0.3 million euros, and the payoff period is estimated to be 2.3 years. And this includes everything that is related to the 5,200 sensors that is installed. So that's the beauty of the simple business model. Thank you very much. I think my time is out now. I'm happy to answer any questions.
Thank you very much for the very interesting presentation. May I please invite the commentators to make suggestions? Thank you.
Right, I can start.
Well, I can start it. Okay, go on, Henrik.
Okay, so the AI engine that you are using, is that unique for every building, or is that the same kind of AI engine that is used for all projects, all buildings?
One might say that the engine is general, but the models are unique. Actually, each room has their own model, and each energy meter has their own model. So it depends on where you draw the line, but I think what you mean is that yes, it's unique. So and it's also adapting. So if let's say that a tenant move out and a new tenant come in that have different user behavior and maybe more internal loads, with time that new behavior will be included in the new model.
Okay.
So we retrain the model every night.
Yeah. And the second question is, you have a lot of data that comes in and you make decisions and you try to kind of stabilize the systems and keep constant temperature and so on.
Yes.
One thing is temperature. The other one is the experience temperature. Do you also get in data like feedback from the users, and how is that handled?
I mean, I would say if you're talking temperature, that is a very subjective. I mean, we can measure, but what one person believes is the comfortable temperature is very. And I mean, we try to do the best we can with measuring it. There is different type of methods of measuring temperature. Today we're measuring the air temperature. You could also measure radiation, etc. But today we only measure normal measurement. But our experience is that if you keep the temperature within the allowed interval, and the allowed interval is decided by the client, the clients are happy. Our biggest clients have reduced their error complaints with 23%. And they recently won a big prize called the Big Indoor Climate Prize. A bit silly maybe, but they won it, and that was due to improving the indoor climate as much. So I would say that there's always almost an equal amount of clients that buys us for the energy savings, but many buys us also for the indoor climate. So it's some people says we don't care as long as we're not increasing the usage. We would like to reduce our complaints. And for us, it doesn't really matter. Just tell us what we should optimize on, and the system can do that.
Yeah, I think that's great news, because I mean, every landlord wants decreased operational costs, but we want happy tenants.
Yeah,
so that's what we're looking for. If you can solve that, I'll work with you.
Mm-hmm. Yeah, I mean, we have a good track record on improving the indoor climate, and that's why I wanted to show this firm example of the reality. And the trickiest thing is actually the clients are not always, they don't know how poor the indoor climate might be before you start measuring. So that could be a little bit of an eye opener for them.
I think Magnus had, yeah.
Yes, thank you. Yeah, great presentation and great technology, etc. So thanks for that, Anders. You said you're measuring, I mean, obviously the indoor climate, temperature, you mentioned humidity, which could be very interesting in Asia, for example, and so on. CO2 is starting to be more and more interesting for companies, according to my experience around the world, to measure, because it's about productivity and user experience, etc. But another area which I've seen around the world that's very interesting is to measure is about pollution. Is that something you also, especially in larger cities like could be London, New York, Los Angeles, but also perhaps Bangkok or other cities? Is that something you're measuring as well?
I'm actually next week. I'm meeting a company. We don't produce any sensors ourselves. We just buy all those services. I'm meeting a company that are specialized in air quality. I'm not very good at it, but it's called PM 2.5 and all those. You can measure different stuff and dust, etc. So I believe that could be very interesting. We don't have those problems where we operate right now, but we're floating in Qatar right now in the Middle East, and there they have sand. Yeah. Sometimes less ventilation is good because you don't want to get the dust in. So that's definitely, but we've built the system. So as long we can define the numbers, the allowed range, the AI will sort of find the patterns and how to try to keep those values up or down or whatever we tell it to do.
Yeah. No, I just, because this is a session, I mean, to ask questions, but also to comment and perhaps give some thoughts or ideas, whatever. I mean, I know, for example, one very large company in London who actually decided to move from one site to another because of the pollution in that specific area in London. So I think this is starting to be more and more interesting to measure as well. So food for thought. Another question. Another question I had is around system integrations, and I mean, Myrspoven is not unique in doing that. Most companies try to do that, and that's what the clients want. But do you face any challenges? I mean, in theory, it's always easy to sort of integrate and then continue to be integrated as everybody's developed their own softwares and bugs can come up, and how do you work with those challenges?
We have not. Some people install the hardware and go into directly into the communication skills, communication slings. Our solution it's not the fastest one, but we actually try to build a relationship with the BMS providers. Like we have Schneider and Siemens, and we're a bunch of smaller ones, and we're trying to, because we want to integrate in the buildings the way they want the integration to be done, and we believe that's very important. So we're not a parallel system. We're actually an add-on to their already existing system, and that is the way forward, we believe, because if there's these buildings are not static. They're experiencing refurbishment all the time, and things break and everything. So we believe it's very important to spend the time it takes to do the proper integration. If it's a Schneider system, we have got help from Schneider and done using their API, and same thing with Siemens, and same thing with Honeywell, and same thing with smaller brands. Some are easy, some are hard, but that's our take on it.
Okay, thank you.
I have a question for you. So thank you for a great presentation. And I also read the presentation that we had sent before. I really love the name. I don't know if everyone else knew it before, but it's actually a bird's name, right?
It's correct.
So, yeah. So my question, what I hear you say is that you are customizing when you deliver your service. So I have a question regards to growth and scalability. How will you manage to scale your business as you are making specific installations in all the buildings?
I would say it's not very. I mean, let's say for Schneider building now, and Schneider has a fairly big market share. We have spent maybe 2,000 hours on building the integration, but for now to connect a building that runs Schneider, we're talking about less than a day to do the actual integration. The only thing we need from the client is username and password for an admin user that is allowed to read and write signals in and start scripts, etc. in the Schneider system. So for the client side, it's very easy. Sometimes we need a VPN connection as well, but we never touch the buildings. We don't need to visit them. We don't know how they look or anything. We have a one-time for each new system. We have a one-time work. So we sort of start we have the 3 integrations to the 3 biggest BMS providers now in Sweden, and we're trying to enter new markets, and then we sort of pick the big ones in those countries as well. A little bit of an 80-20 rule, but from the client side, it's not a lot of work at all. It's only a one-time investment for us to do the integration.
Sounds great. Congratulations to great business, I would say. I really like what you do.
Thank you. Thank you.
Thank you very much. We run out of time, but I thought just to point out that what Magnus brought up about PM 2.5, that's a big problem in Thailand. So I was hoping maybe there was time for the Thai commentators to make suggestions on that. But I think there will be opportunities to reconnect if there are any further comments and suggestions.
Yes,
any Thai comments would like to make, like last comments from Thailand?
Well, I'd just like to congratulate you. I think the solutions and the platform you have built is remarkable, and I think will be very beneficial for the Asian market as well.
Thank you, and don't hesitate to reach out. And I'm very interested in both getting to know potential client, but also potential partners. So if you know anyone that might want to work with us, please let them know.
Right, so we're in the wrapping up sessions, and I would like to thank all the speakers and all the commentators again for the excellent companies pitching and very insightful and food for thoughts. We found that there are so many effective usages of today's technology, and there's so much innovation both from the Thai side and the Sweden side. And which it looks like you're already adapting towards a post-COVID world, but an emerging sort of, maybe it's an old problem, but a technical problem it seems to be surrounding data and the cloud. So is this something that maybe a topic that we could follow up on maybe for next time that we meet? I'm not sure if there are plans to to have this forum as an annual event, but if we do, then maybe that could be one of the topics. So I would like to thank you so much again.